Ever wonder who invented awesome science stuff way back? Let me tell you, Muhammad al-Razi was a doctor who helped sick people long ago. Al-Farghani was a space expert. He studied the stars. And al-Battani? He figured out how to track the sun and moon. Muslim scholars made science super cool. Abu Abdullah al-Battani, 868, 929 CE. Abu Abdallah Muhammad ibn Jabir. Ibn Sinan al-Battani al-Harani was born around 858 CE in Haran, and according to one account, in Batan, a state of Haran. Battani was first educated by his father, Jabir ibn Sanan al-Battani, who was also a well-known scientist. He then moved to Raqqa, situated on the bank of the Euphrates, where he received advanced education and later on flourished as a scholar. At the beginning of the 9th century, he migrated to Samarra, where he worked till the end of his life in 929 CE. He was of Sabian origin but was himself a Muslim. Al-Battani is sometimes known by a Latinized version of his name, variants being Albatanius, Albatani or Albatinius. His full name was Abu Abdallah Muhammad ibn Jabir, ibn Sinan al-Raqi al-Harani al-Sabi al-Battani. Al-Battani was born in Haran, called Karhai in earlier times by the Romans, which lies on the Balik River, 38 kilometers southeast of Urfa. His family had been members of the Sabian sect, a religious sect of star worshippers from Haran. Being worshippers of the stars meant that the Sabians had a strong motivation for the study of astronomy, and they produced many outstanding astronomers and mathematicians, such as Thabit ibn Qurra. In fact, Thabit was also born in Haran, and would have still have been living there at the time that al-Battani was born. Al-Battani, unlike Thabit, was not a believer in the Sabian religion, however, for Abu Allah Muhammad indicates that he was certainly a Muslim. Although the identification is not absolutely certain, it is probable that al-Battani's father was Jabir ibn Sinan al-Harani, who had a high reputation as an instrument maker in Haran. The name certainly makes the identification fairly certain, and the fact that al-Battani himself was skilled in making astronomical instruments is a good indication that he learnt these skills from his father. Al-Battani made his remarkably accurate astronomical observations at Antioch and Ar-Raqqa in Syria. The town of Ar-Raqqa, where most of al-Battani's observations were made, became prosperous when Harun al-Rashid, who became the 5th caliph of the Abbasid dynasty on the 14th of September, 786, built several palaces there. The town had been renamed Al-Rashid at that time, but by the time al-Battani began observing there, it had reverted to the name of Ar-Raqqa. The town was on the Euphrates River just west of where it joins the Balik River, on which Haran stands. The Fihrist Index was a work compiled by the bookseller Ibn an-Nadim in 988. It gives a full account of the Arabic literature which was available in the 10th century, and it describes briefly some of the authors of this literature. The Fihrist describes al-Battani as, see for example, one of the famous observers and a leader in geometry, theoretical and practical astronomy, and astrology. He composed a work on astronomy, with tables, containing his own observations of the sun and moon, and a more accurate description of their motions than that given in Ptolemy's Almagest. In it, moreover, he gives the motions of the 5 planets, with the improved observations he succeeded in making, as well as other necessary astronomical calculations. Some of his observations mentioned in his Book of Tables were made in the year 880, and later on in the year 900. Nobody is known in Islam who reached similar perfection in observing the stars and scrutinizing their motions. Apart from this, he took great interest in astrology, which led him to write on this subject too. Of his compositions in this field, I mention his commentary on Ptolemy's Tetrabiblos. Other information about al-Battani contained in the Fihrist is that he observed between the years 877 and 918, and that his star catalogue is based on the year 880. It also describes the end of his life, which seems to have occurred during a journey he made to Baghdad to protest on behalf of a group of people from Ar-Raqqa because they had been unfairly taxed. Al-Battani reached Baghdad and put his arguments but died on the return journey to Ar-Raqqa. The theorist also quotes a number of works by al-Battani. There is his Kitab al-Zij, which is his major work on astronomy with tables, referred to above. We shall examine this in more detail in a moment. There is also the commentary on Ptolemy's Tetrabiblos, referred to above, and two other titles, on ascensions of the signs of the zodiac and on the quantities of the astrology cal applications. One of the chapters of the Kitab al-Zij has the title, On Ascensions of the Signs of the Zodiac, and so the theorist may be wrong in thinking this is a separate work. This point still appears unclear. Al-Battani's Kitab al-Zij is by far his most important work, and we should examine briefly the topics which it covered. The work contained 57 chapters. It begins with a description of the division of the celestial sphere into the signs of the zodiac and into degrees. The necessary background mathematical tools are then introduced, such as the arithmetical operations on sexagesimal fractions and the trigonometric functions. Chapter 4 contains data from al-Battani's own observations. Chapters 5 to 26 discuss a large number of different astronomical problems following to some extent material from the Almagest. The motions of the Sun, Moon, and 5 planets are discussed in chapters 27 to 31, where the theory given is that of Ptolemy, but for al-Battani the theory appears less important than the practical aspects. After giving results to allow data given for one era to be converted to another era, al-Battani then gives 16 chapters which explain how his tables are to be read. Chapters 49 to 55 cover problems in astrology, while chapter 56 discusses the construction of a sundial, and the final chapter discusses the construction of a number of astronomical instruments. What are the main achievements of al-Battani's Zij? He catalogued 489 stars. He refined the existing values for the length of the year, which he gave as 365 days, 5 hours, 48 minutes, 24 seconds, ons, and of the seasons. He calculated 54.5 inches per year for the precession of the equinoxes and obtained the value of 2335 and for the inclination of the ecliptic. Rather than using geometrical methods as Ptolemy had done, al-Battani used trigonometrical methods which were an important advance. For example, he gives important trigonometric formulas for right-angled triangles such as b sin A equals sin 90 A. Al-Battani showed that the farthest distance of the Sun from the Earth varies, and as a result, annular eclipses of the Sun are possible as well as total eclipses. However, as Swerdlow points out in 8, the influence of Ptolemy was remarkably strong on all medieval authors, and even a brilliant scientist like al-Battani probably did not dare to claim a different value of the distance from the Earth to the Sun from that given by Ptolemy. This was despite the fact that al-Battani could deduce a value for the distance from his own observations that differed greatly from Ptolemy's. In one, Hartner gives a somewhat different opinion of the way that al-Battani is influenced by Ptolemy. He writes, "While al-Battani takes no critical attitude towards the Ptolemaic kinematics in general, he evidences a very sound skepticism in regard to Ptolemy's practical results. Thus, relying on his own observations, he corrects, be it tacitly, be it in open words, Ptolemy's errors. This concerns the main parameters of planetary motion no less than erroneous conclusions drawn from insufficient or faulty observations, such as the invariability of the obliquity of the ecliptic or of the solar apogee. Al-Battani is important in the development of science for a number of reasons, but one of these must be the large influence his work had on scientists such as Tycho Brahe, Kepler, Galileo, and Copernicus. In 5, there is a discussion on how Al-Battani managed to produce more accurate measurements of the motion of the Sun than did Copernicus. The author suggests that Al-Battani obtained much more accurate results simply because his observations were made from a more southerly latitude. For Al-Battani, refraction had little effect on his meridian observations at the winter solstice, because at his more southerly side of Ar-Raqqa, the Sun was higher in the sky. Al-Battani's Kitab al-Zij was translated into Latin as De Motu Stellarum, on the motion of the stars, by Plato of Tivoli. This appeared in 1116, while a printed edition of Plato of Tivoli's translation appeared in 1537 and then again in 1645. A Spanish translation was made in the 13th century, and both it and Plato of Tivoli's Latin translation have survived. Al-Farghani, c. 860 CE, Abul Abbas Ahmad ibn Muhammad ibn Kathir al-Farghani, born in Farghana, Transoxiana, was one of the most distinguished astronomers in the service of al-Ma'mun and his successors. He wrote, Elements of Astronomy, Kitab fi al-Harakat al-Samawiyya wa Jawami Ilm al-Nujum, that is the book on celestial motion and thorough science of the stars, which was translated into Latin in the 12th century and exerted great influence upon European astronomy before Regiomontanus. He accepted Ptolemy's theory and value of the precession, but thought that it affected not only the stars, but also the planets. He determined the diameter of the Earth to be 6,500 miles, and found the great S distances and also the diameters of the planets. Al-Farghani's activities extended to engineering. According to Ibn Tugri-Birdi, he supervised the construction of the Great Nilometer at Al-Fustat, Old Cairo. It was completed in 861, the year in which the Caliph al-Mutawakkil, who ordered the construction, died. But engineering was not Al-Farghani's forte, as transpires from the following story narrated by Ibn Abi Usaybiyah. Al-Mutawakkil had entrusted the two sons of Musa ibn Shakir, Muhammad and Ahmad, with supervising the digging of a canal named Al-Jafari. They delegated the work to Al-Farghani, thus deliberately ignoring a better engineer, Sind ibn Ali, whom out of professional jealousy they had caused to be sent to Baghdad, away from Al-Mutawakkil's court in Samarra. The canal was to run through the new city, Al-Jafariya, which Al-Mutawakkil had built near Samarra on the Tigris and named after himself. Al-Farghani committed a grave error, making the beginning of the canal deeper than the rest, so that not enough water would run through the length of the canal except when the Tigris was high. News of this angered the Caliph, and the two brothers were saved from severe punishment only by the gracious willingness of Sind ibn Ali to vouch for the correctness of Al-Farghani's calculations, thus risking his own welfare and possibly his life. As had been correctly predicted by astrologers, however, Al-Mutawakkil was murdered shortly before the error became apparent. The explanation given for Al-Farghani's mistake is that being a theoretician rather than a practical engineer, he never successfully completed a construction. The Fihrist of Ibn al-Nadim, written in 987, ascribes only two works to Al-Farghani. 1. The Book of Chapters, a summary of the Almagest, Kitab al-Fusul, Ikhtiyar al-Majisti, and 2. Book on the construction of sundials, Kitab Amal al-Rukamat. The Jawami, or the Elements as we shall call it, was Al-Farghani's best-known and most influential work. Abdalaziz al-Kabisi, d. 967, wrote a commentary on it, which is preserved in the Istanbul manuscript, Aya Sophia, 4832, Fols, 97 v. 114 v. Two Latin translations followed in the 12th century. Jacob Anatoli produced a Hebrew translation of the book that served as a basis for a third Latin version, appearing in 1590, whereas Jacob Golius published a new Latin text together with the Arabic original in 1669. The influence of the Elements on medieval Europe is clearly vindicated by the presence of innumerable Latin manuscripts in European libraries. References to it by medieval writers are many, and there is no doubt that it was greatly responsible for spreading knowledge of Ptolemaic astronomy, at least until this role was taken over by Sacrobosco's sphere. But even then, the Elements of Al-Farghani continued to be used, and Sacrobosco's sphere was evidently indebted to it. It was from the Elements in Gerard's translation that Dante derived the astronomical knowledge displayed in the Vita Nuova and in the Convivio. Muhammad ibn Zakaria al-Razi, 864-930 CE, Abu Bakr Muhammad ibn Zakaria al-Razi, 864-930 CE, was born at Ray, Iran. Initially he was interested in music, but later on he learnt medicine, mathematics, astronomy, chemistry and philosophy from a student of Hunayn ibn Ishaq, who was well versed in the ancient Greek, Persian and Indian systems of medicine and other subjects. He also studied under Ali ibn Rabban, The practical experience gained at the well-known Muqtadari Hospital helped him in his chosen profession of medicine. At an early age, he gained eminence as an expert in medicine and alchemy, so that patients and students flocked to him from distant parts of Asia. He was first placed in charge of the first royal hospital at Ray, from where he soon moved to a similar position in Baghdad, where he remained the head of its famous Muqtadari Hospital for a long time. He moved from time to time to various cities, special lie between Ray and Baghdad, but finally returned to Ray, where he died around 930 CE. His name is commemorated in the Razi Institute near Tehran. Razi was a hakim, an alchemist and a philosopher. In medicine, his contribution was so significant that it can only be compared to that of Ibn Sina. Some of his works in medicine, for example, Kitab al-Mansuri, al-Hawi, Kitab al-Muluki, and Kitab al-Judari wa al-Hasaba, earned everlasting fame. Kitab al-Mansuri, which was translated into Latin in the 15th century CE, comprised 10 volumes and dealt exhaustively with Greco-Arab medicine. Some of its volumes were published separately in Europe. His al-Judari wa al-Hasaba was the first treatise on smallpox and chickenpox, and is largely based on Razi's original contribution. It was translated into various European languages. Through this treatise, he became the first to draw clear comparisons between smallpox and chickenpox. Al-Hawi was the largest medical encyclopedia composed by then. It contained on each medical subject all important information that was available from Greek and Arab sources, and this was concluded by him by giving his own remarks based on his experience and views. A special feature of his medical system was that he greatly favored cure through correct and regulated food. This was combined with his emphasis on the influence of psychological factors on health. He also tried proposed remedies first on animals in order to evaluate in their effects and side effects. He was also an expert surgeon and was the first to use opium for anesthesia. In addition to being a physician, he compounded medicines and, in his later years, gave himself over to experimental and theoretical sciences. It seems possible that he developed his chemistry independently of Jabir ibn Hayyan. He has portrayed in great detail several chemical reactions and also given full descriptions of and designs for about 20 instruments used in chemical investigations. His description of chemical knowledge is in plain and plausible language. One of his books, called Kitab al-Asrar, deals with the preparation of chemical materials and their utilization. Another one was translated into Latin under the name Liber Experimentorum. He went beyond his predecessors in dividing substances into plants, animals, and minor als, thus in a way opening the way for inorganic and organic chemistry. By and large, this classification of the three kingdoms still holds. As a chemist, he was the first to produce sulfuric acid together with some other acids, and he also prepared alcohol by fermenting sweet products. His contribution as a philosopher is also well known. The basic elements in his philosophical system are the creator, spirit, matter, space, and time. He discusses their characteristics in detail, and his concepts of space and time as constituting a continuum are outstanding. His philosophical views were, however, criticized by a number of other Muslim scholars of the era. He was a prolific author who has left monumental treatises on numerous subjects. He has more than 200 outstanding scientific contributions to his credit, out of which about half deal with medicine and 21 concern alchemy. He also wrote on physics, mathematics, astronomy, and optics, but these writings could not be preserved. A number of his books, including Jami fi al-Tib, Mansuri, al-Hawi, Kitab al-Judari wa al-Hasaba, al-Maluki, Makala fi al-Hasat fi Kuli wa al-Mathana, Kitab al-Qalb, Kitab al-Mafasil, Kitab al-Ilaj al-Ghuraba, Bar al-Sa'a, and al-Taqsim wa al-Taqsir, have been published in various European languages. About 40 of his manuscripts are still extant in the museums and libraries of Iran, Paris, Britain, Rampur, and Bankipur. His contribution has greatly influenced the development of science in general, and medicine in particular.